Hey, hi, hello, what's up, guys? We are back again with another problem. In today's problem, we are given an integer n with some digits, and we are allowed to rearrange those digits, and we need to return true if it is similar, it is equal to any power of 2. So let's say we are given a number 6 1. So can we arrange 6 and 1 in a way that it is a power of 2, any power of 2? So any power of 2, that can be 4, 2, that can be 4. So 2 raised to 2 is 4. So that would be 1 and 6 as shown in this example, and as well as this example. So it's 46. 46 can be converted to 64, which is 2 raised to the power something. 6, 2 raised to the power 6, which gives us the answer. But 24 cannot be converted into anything. It can be 4 and 2, but that makes 42, and 42 is in the power of something. So there are few basic approaches. The first thing that came to my mind instantly was I need to try to permutate each and every one of them, and I need to check if it's a power of 2. But checking if it's a power of 2 or not takes certain amount of time, and permutation of these numbers will also take a huge amount of time. But I came a bit farther when I thought that if a 0 is present, we won't include the 0 because a leading number cannot start with a 0. And then I came up with things like if it's all odd numbers, then we don't need to calculate anything because our number cannot be odd. I mean, if it is 1 1, both the numbers are odd, it cannot be a power of 2 because it's not divisible by 2, and so on. But that would not do much for the time complexity part. And the second thing that came to my mind is I'll calculate the number of the digits present, the frequency of digits present, and then I'll check if each power of 2 has these number of frequency or not. Although that's a good solution, but it's a bit it is in the implementation path that you should really worry about the time complexity, because if you use a function called power of 2 that takes log n time complexity in calculating that power of 2, so it's a bit okay, but that can be simplified by multiplying the number by 2, or in bitwise what we can do is we can just shift 1 to its whatever place, whatever the power of 2 we want. So I created this function. This function is find the digits. It's simply mapping a digit to a array. So I created an array of 0 to 9, and then I mapped each and every number there. So if it was let's say the last number was 1, 10, I got it. So it's like 1 and 6 for our 16 example. Then I came back here. First I needed the original digits of my number n that was given to us, so I got it 1 and 6. Then I needed this function to calculate the digits of all the power of 2, or what could I have done is I could have pre-calculated it and kept it somewhere, but calculating that takes certain amount of time, and we need to calculate it for the 2 raised to the power 30 because the number given is 10 to the power 9. So I think 2 raised to the power 30 would do it. But if we try to do it and store the value of all these for all of the power of 2 till 30, then we would require a lot of space and time. But using this, what we can do is we can call it for each and every digit. So let's say we are calling it for 1 right now because it's starting at 0. Then we call it for 2, 3, 4, 5, and so on. And we check if they are equal or not. So there in a string there's a method present called equals, so that compares each value and not the reference. And this is the same thing, this compares the value of this and this. If they are same, it returns true, and if this is true, we can simply return true. But if this is false for all the 30 powers of 2 to the power 0, 1, 2, 3, 4, and so on, if this is false, we can most certainly return false. And that was it for this video, guys. It wasn't a much of a solution though. I mean, there's not much explaining that needs to be done here, and that's it for this video, guys.